In this part, we'll go over 3 strategies you can use to help get feedback about what might be causing a problem. So this can be from other people and also from the code itself. A surprisingly effective strategy is just explaining the problem to another person. So when you describe a bug out loud, something interesting often happens, which is that you clarify your thinking, you revisit assumptions, or you may suddenly notice the mistake yourself as you're talking. Programmers sometimes call this the rubber duck debugging technique. You literally explain your code step by step to a rubber duck sitting on your desk. More often than not, the explanation itself reveals the solution. So some tips you can use when you're doing this: just explain, don't just show the error, explain how the program is meant to work line by line, and explain why the behavior you see is not the behavior that you expect. So here's how you can try this yourself. Next time you run into a problem with your code that you can't solve, ask one of your classmates in the tutorials if they would be happy for you to try and talk through your problem with them. Do your best to talk through what the code is doing line by line, explaining what you think it should be doing and what actually seems to be happening. Of course, you might not know the answer, but maybe this will help you think through it. And of course, you can get feedback from that other person as well. If you're not in a tutorial, you could make a post in the Coding Problems discussion forum with a link to your code in the online editor and then add an explanation as a reply. Or if you really like, you could go out and get your favorite rubber ducky and tell your coding problems to the rubber ducky. Our next strategy is to use the console to log, which means to really print out information as the program is running. And the console is one of the most useful and powerful debugging tools available to you. In JavaScript, you can print information to the console using the command console.log. It allows you to inspect things like variable values, understand program flow, and check whether certain functions are being executed or not. Console logging helps you understand what your program is actually doing rather than what you think it should be doing. So here's how you can try this yourself. Open up the link that's provided here to go to the live version, and you'll see some code that if you run it, you'll get an error, and it'll say something about there's an error with loading an image. Now, loading images we'll cover in week 4 tutorials, so don't worry too much if you haven't tried that out yet. We're really just going to concentrate on console.log in this example. What I want you to do is add in a line after line number 5 in the code that says console.log and then round brackets and then just that variable I. And then run the code again and look at the value of I as it gets printed out on the console. And what I want you to look at is the name of the file name that's trying to be loaded there. That's on line 6. That's a pretty big clue to what's going wrong. If you want to pause the video, go off and have an attempt at that and then come back once you're done. Okay, so how did you go? Maybe you tried that. Maybe you're just powering through the lecture with me. Let's swap into that and try it out together. So here I have the code, and I was playing with this myself before, so I'm going to just refresh that and then run it from the start. And if I look at my console, I get that error that I was talking about. P5 says, it looks like there was a problem loading your image. Try checking if the file path is correct. And then it has a whole bunch of other information there, which is not too useful to us. Now, this one doesn't really have a good line number, but whenever I run into this particular problem, I usually know it's something that might be going wrong in the preload function. And you'll learn more about this in week 4's tutorial. So that's why I said we should add in a console.log with round brackets and just that number, that value of I in the preload. So let's just check what value of I we're using each time. So if I run that again, I get the same error message, but notice this time I've got that those 5 numbers out there, 1, 2, 3, 4, 5. Those are the numbers of that's in the variable I as it's going through this for loop. And if we look on line 7, we're actually using that to create a file name that we're trying to load in as an image. So it's going to be 1.png, 2.png, all the way up to 5.png. Now, when you get this error about maybe not being able to load a file, and you're loading it in from your sketch here on the Explorer, you want to check that that name that you're putting in is actually there. And you can see here I've got 0.png, 1, 2, 3, 4.png. So it doesn't go up to 5.png, and there's also an extra one, 0.png. So that tells me that this for loop has actually got a little mistake. It should start from 0, not 1, and go up to 4, not 5. So if I run that again, it should work, and you'll see a very dizzy Jared on the right-hand side. Whoa, it's been a busy week. So using console.log helps us see what's going on inside that for loop, and otherwise that's very difficult to do. Another useful technique in creative coding is what I call on-canvas debugging. So instead of printing information to the console, you can also display information visually on the canvas. So you might draw coordinates or bounding boxes or shapes that tell you something about how the code is working. And this can make it easier to understand what's happening visually in a graphics-based program. So here's an example that allows you to try this out on this on-screen debugging technique yourself. Open up the link, and the code that's linked there draws this simple robot face. But you'll see, and you can see in the thumbnail here, the mouth is a bit wonky. Okay, so let's say that what we wanted to do was have a robot that has a perfectly symmetrical mouth. Open up the link, run the code, and then use the on-screen coordinates of the X and Y position to figure out what coordinates we should draw the rectangle at. You can pause the video there and come back once you've had a go at it. Okay, so how did you go? Let's open up the code, and I've got it here in my editor. If I run that, we'll get that wonky-mouthed robot. And when I put my mouse over the screen, I can see here the X coordinate and the Y coordinate of my mouse, wherever it is. And that's from this little line here, line 24, text X plus mouse X, Y plus mouse Y, mouse X, mouse Y. So it's just creating a little message in this first part, which is just X 200, Y 300 or whatever they are, and then it's drawing that message at mouse X, mouse Y. And that's the tip of the little arrow. So I can see that my rectangle here is drawn at about X equals 120 something and Y equals 240 something. If I check that over here in the code, here it is. X is drawn at 120, Y is drawn at 240. So I'm thinking probably what I want to do is draw my mouth so it lines up with the left-hand side of this eye, and that looks like it's about X equals 90. So let's just change the code to 90 here, not 0, 90. Stop it and run it again, and there we've got a very beautiful, nicely symmetrical robot. Now, of course, you could also do that by doing the maths and figuring out what this distance here is, but like if you look at the circle, it's actually drawn with the X value of 120 because that's the center of the circle. So using the coordinate can just make it a little bit quicker and easier to do. Right, I'll just undo that so it's still a problem for the next person who comes here, and we'll pop back into the lecture. So in this part, we've looked at 3 strategies you can use to help yourself get feedback about your code, either from other people or from the code itself. In the next part, we'll discuss the use of generative AI and creative coding.